Okay, so I quickly want to discuss what similar triangles are and then go ahead and do a couple of examples. So here we have two triangles, right? So we have triangle ABC and we have triangle DEF. So I'm going to go ahead again, notation, triangle, right? Literally a triangle, triangle ABC, right? And then I have triangle DEF, right? Okay, so what do we mean by similar triangles? Okay, now let's go ahead and I'm going to write the symbol. This little squiggly sign, right, literally means, that's an arrow, means similar, So triangle ABC is similar to triangle DEF. Okay, couple of things. This triangle, right, well, we obviously have two triangles. We have the same shape, but we have a different size. So these are actually scale drawings, right? Architects, engineers, right? Interior decorators use scale drawings all the time to plan their work. So these are scale drawings, but we say that these are similar triangles or similar figures. And there's some important properties to these similar figures, or in this specific case, similar triangles. Okay, so what are these properties of these similar triangles? Well, if triangle ABC is similar to triangle DEF, then we know that, so let me maybe start, this angle, okay, has the same measure as angle D. So we call those corresponding angles. Okay, now we don't actually know the measure in this case, so I'm not going to write an M. So I'm just going to say angle A and angle D. Okay, so let's write have the same measure. Okay, so if one was 30, the other would be 30 again, but we don't know that it's 30. Have the same measure, right? But we also say angle A and B, we really want to say are corresponding angles. Corresponding angles. Okay, and that's the terminology we want to use. So angle A and angle D are corresponding angles. What other angles are corresponding angles? Well, angle B, right, and angle D are corresponding angles, right? And we have to write something different here, not to confuse it with this angle, because if we leave it like this, then we're saying that they're the same angle, but I mean, they could be the same angle, but we don't know that for sure. So I'm going to go ahead and actually with angle A, I'll write one little tick mark here. It's a little tick mark. And here, so angle B, I'm going to write two tick marks, and angle E. So angle B and angle D, right, and I'll just say are corresponding angles. Okay, and the last corresponding angle is going to be angle C and angle F, and we can write maybe 3 tick marks. I wrote my drawing a little bit small, but you really want to do, so I really want to do 1, 2, 3. And so angle C and angle F, again, are corresponding angles. Okay, corresponding angles means they have the same measure. Okay, we have angles, but we also have sides because we have a triangle. So corresponding sides. So if I look at, for example, angle B and angle D, okay, the opposite of angle B is this length, right? And the opposite of angle E is this length. And notice I put it pink and pink. So those sides, all right, correspond. So let's write this down. So we can say the length of A, let's see, it was at AC, corresponds, right? And I'm actually going to go ahead and draw a division bar there, and I'll tell you why in a bit. And the length of, let's see, AC to DF. And just a short notation here, anytime you want to talk about a length. So AC, I'm going to draw a little bar. So the length of AC, I'm talking about this guy. And the length of DF is this guy. So that's, should actually maybe do it in pink here. The length of DF, right? Those are corresponding sides. Now, corresponding angles have the same measure, but corresponding sides are not necessarily equal, right? Because this guy is definitely smaller than this guy. So let's go ahead and write out the other sides. So we have, so let's color code here. So blue, so we have the length of, let's see, AB corresponds to the length of, well, here's AB, and here's DF, so DE actually, DE, so short notation, the length of AB corresponds to the length of DE. And then finally, my white is, let's see, CB, right, or BC, CB and FE, CB and FE, so CB and FE, and I'll let you guys write that in if you'd like. Okay, so let's give this triangle some lengths, right? So I'm gonna say this guy is from CA, that's going to be 6 inches, and that's going to be 3 inches, so half of it. This guy, CB, is going to be 8 inches, and so this guy I'm going to make half, and so half is going to be 4. AB is going to be 4, and then half of it is going to be 2. Okay, so now if we insert these guys, well, what is AC? AC is AC is 6. Let's do pink. Well, we don't have to do pink. AC is 6. What's DF? DF is 3. Okay, AB is 4. DE is 2. And we have CB and FE. So CB is 8 and FE was 4. Okay, so the main point here is I want you guys to see, okay, all of these guys, right, equal 2. So similar triangles, okay, corresponding angles have the same measure, okay, but the ratios, remember ratios, talked about rational numbers, right? Ratios, when you divide the sides, the ratios of the lengths, right? The ratios of the lengths, the ratios of the lengths, right? The ratios of the lengths of these corresponding sides, right, are actually equal. Okay, they're not equal if, well, they're not if they're not equal, then they're not similar triangles. So I'll go ahead and stop here. This is actually also on page 621, 622 of your book. They give you a little bit more information, but you have to understand what corresponding angles are and corresponding sides. And then the problems are actually, they're actually very, very short. You just have to set up the proportion. That's actually the kind of trick. And I will, let's see, let you guys look at number or example 3, if you'd like, in your book, using similar triangles. There's more than one way on how to set this up. So if you don't exactly use the proportion they use in the book, that's fine, as long as you get the same answer, then you're fine. Example 4 is also very, very nice. Okay, I'll go ahead and stop here. Let's see, any other problems I want to do? I think that's it. So I'll see you guys in class. And oh, it's Easter today, so happy Easter. Little smiley face, or actually I should draw a bunny. Let's see if I can do a bunny. There's my, is that a bunny? Looks like a dog. There's my bunny. Happy Easter.